So welcome, Alistair. He's going to talk to us about scaling Magento database. Welcome.
Cheers. Cheers, everyone. I realize I stand between you and either going home or going to the bar. So we'll keep this relatively fast-paced and hopefully interesting and informative. The title did change. I took the advice. So we're looking at scaling data in Magento. But a brief introduction. I'm Alistair Stead. I'm CTO at Session Digital. We're a solution partner based in London. So we're looking at the effects of seasonal trends, marketing activity that genuinely have the capacity to focus traffic into a very small window of time, and as such can genuinely melt CPUs. Not literally, but you look at your charts and your servers will not be responding to the amount of traffic you have. And there's very little point in spending 5- and 6-figure sums on marketing if you can't convert those customers, okay? So it's a real problem. Server capacity can, of course, be expanded. Hardware is inexpensive, but ultimately, if you've got an underlying problem, adding more hardware is only going to make that problem bigger. You might get small incremental improvements in your capacity, but the problem will still be there, and you'll find yourself spending that 5- or 6-figure sum that you would have spent on marketing on hosting. And the problems can be described as back pressure from underlying systems. Systems that aren't responding quickly enough to the volume of requests you're making. And that's often leveled at PHP. And in some cases that may be true. But if you've got another system below that that's causing that back pressure, PHP will manifest the symptoms, which will then be manifested by your web server. So identifying the right place to look is key. When the DB is the bottleneck, you're only going to make it worse by adding more servers. Letting more users through to that same service just exacerbates the problem and potentially makes the problem unrecoverable. And the end result is a server that goes down and you have to put up a static holding page waiting till the traffic's gone away. And that's not a scenario you really want to be in. I'm not a DBA. I'm not a database administrator. I don't claim to be. I've got a lot of experience engineering and diagnosing these problems, but ultimately I know how to call on the expertise of others as well. When your store is popular, you simply have to cope or learn. And that learning curve can be steep. So don't just copy Stack Overflow. Identify the problem, the real problem. Don't just take the answer to a similar sounding scenario. You have to learn to question what's going on and to find the people that can help. Engineering is not a solitary affair. We work in teams, but look outside your team. Look to your hosting partner, look to other service providers. They can all help offer advice and indeed solutions. So you have your store up and running, and we've seen many presentations in the past and indeed today about how to configure Magento and your web servers so they're all running nicely. They scale at the web server level. Magento is configured for optimal running. You're using Redis. You've got full page cache enabled, flat tables. You've got your indexes running. Now you have more traffic. Things are slowing down. What do you do? Well, you can't do anything without instrumentation. You have to know where the problem is. And you can't just point at potential problems. You need to form a hypothesis based on real data so that you can actually see the problem being relieved. You can use developer instrumentation to identify these problems earlier. So knowing how many DB queries a single page takes to render is something that we can kind of forget about, and we can be very lazy while developing. It's hidden away from us. We've got an object relational mapper handling the connection and the query. We're not writing them ourselves, so we don't see them build up. If we have development instrumentation, we can start to take action earlier. But the key is production instrumentation. We run all of our sites with some form of monitoring at a code and process level, so that when there is a problem, we can identify it. And because it's running in production, we can see trends between releases. We can see where the problems are starting to arise. We can start to schedule some maintenance or some of our delivery time in order to pay down some of those problems and fix them. But once we've got the metrics showing that the DB is slowing us down, potentially this becomes a harder problem. We need to take some actions, but first we need to account for some of the terminology that we're going to discuss and some of the terminology you'll see in scaling at the database layer. So scaling, high availability, and redundancy. They are all related, often potentially used interchangeably, but they are different and separate things. So scaling is briefly described, not just taken from Wikipedia, I did put some thought into it, as being able to function within acceptable limits that you would define with a user base that's increasing. Okay, so as your users increase, your application should continue to perform within those limits, not necessarily the same values, but within limits. High availability is the ability to facilitate continuous functionality while suffering a failure, network segmentation, or service outage. That's slightly different to redundancy, where you have a duplication of critical systems, but with high availability, that failure would be seamless to the end user. Okay? So in a mission-critical application, we need to balance all three of those concepts. In commerce, conversion rates, they are directly affected by the performance of our application and also its uptime. If you've got marketing budget being spent and you don't have a system that's highly available, you suffer an outage, those customers will still be responding to the marketing effort, still visiting your website. So you need to ensure that if there's big budgets being spent there, you've got a system that will be highly available. Technology should facilitate that conversion rather than just being held as a blocker to any activities or any plans. And sometimes these big problems can be perceived as a blocker. So effort should be spent kind of finding a strategy and a plan in order to remove those blockers from the ongoing plans of the business that your platform is supporting. So where should we start with the diagnosis? So we've now got a bit of a step plan for solving a problem whereby Apache or Nginx, whatever your web server of choice may be, is waiting on PHP and PHP is waiting on the database. This is a scenario we've seen, and you will see in applications other than Magento, but often PHP gets the blame. It's not to say that any one of these systems is at fault or incorrectly used. It's just identifying where the problem exists. Step one to solving this is make your queries faster. One of the simplest ways we can attack that problem is implementing appropriate MySQL indexes for the query we're running. Very simple queries can often be in the order of seconds to return. Implementing an index will bring those down to milliseconds. So the quicker you can give PHP the information, the quicker the PHP process can release back to your web server, and your customer gets the data and the page, and the next customer can be served. There's also the potential to redesign queries, but I'm not saying we should be delving into the Magento core to do that, but often our custom code can begin to implement new queries. We should genuinely be looking at those and identifying if they're the right structure, if it's the right query. If you find in your particular case, there are certain use cases where you may look at a query and say, for my data set, this alternate query structure would be quicker. I'd urge everyone that when you identify scenarios like that, provide a patch back to the Magento team with the clear data set that exposes that scenario, because it may be an uncommon edge case or a very unique business scenario that drives that. Step 2 is cache. As much of it as you can in as many places as you can. Expand query cache as much as you can. It is feasible to consider fitting your entire database into memory as part of query cache. So every query that's executed that can be cached will be. That means you get a much better throughput from the same database queries without any modification. Use full page cache. It's stating the obvious, but it will protect your database at peak loads. And use proxy or edge caches. If you don't need to bootstrap the Magento application, if you don't need PHP to execute, then why would you? Okay? With all of those suggestions for cache, at some point, your cache must expire. On sites that are merchandised constantly, where stock is replenished constantly or changing constantly, cache just isn't effective. And we've had a number of scenarios where at peak load, at peak merchandising seasonal trends, cache just simply wasn't an option. We had to make the raw hardware support the numbers of traffic that we were sending at the servers. Cache can still help you in certain scenarios, but you still need to optimize further. And all of the scenarios we've just described are about read operations. We're a transactional e-commerce website, so there's write operations in there somewhere. We need to have some strategy for dealing with those. Often with write operations, lock weight will be often a common barrier in many scenarios. And your exception log probably will include at some point a lock weight timeout on a write operation. That's caused by the database engine protecting data integrity. Two users can't write to the same resource at the same time with differing data, so locks are created to protect from that. And if you're waiting for those locks to be released, the query will eventually time out. The easiest way to avoid that is to ensure that all your tables are in InnoDB. We've seen on a number of projects, legacy code bases or legacy modules still creating MyISOM tables. That's the engine that runs the table is storing data with and accessing data with. Increasing lock weight timeout. It'll make the exception go away, but it won't fix your performance. It'll actually just make users wait as long as you set that value before receiving the same exception. Okay? Now, in certain scenarios, maybe in the admin function, that would be feasible. It would be what you want. But in client-facing functionality, if there's going to be a deadlock situation, you want to exit early so you can serve the next customer. Okay? So we've seen if you Google for lock weight deadlocks, the probably first and second on Stack Overflow is to extend this value. Don't do it, it's an anti-pattern. Also, look at transaction level. The default with MySQL is repeatable read. It's a safe setting for MySQL. It means you'll get consistent data, very, very consistent transactions. It doesn't need to be that high. Use read committed as an alternate value. The transaction isolation is still sufficient. We've run this at high volume production. We get a much better throughput, vastly reduced deadlock scenarios, and no data integrity problems. Reduce transaction size. One of the problems that we often encounter is work being done inside of a transaction. So we've opened a transaction and a connection to MySQL. We're then doing work to connect to a third-party service, often an API call or an external interaction from Magento to some other system. Whilst that transaction's open, you've got a lock. which means you're blocking any other actions. So we often find ourselves reducing what's in a transaction, first of all, potentially removing some of the update statements that are non-critical and offloading those outside of that transaction to a worker queue. So we can get the critical transaction data saved as quickly as possible and release that lock back to the remaining users. Step 7, reduce non-critical write operations. This might be controversial, because I'm saying don't do logging. Yes, we're going to lose some functionality, but there's loads of other services that can deliver that same functionality without preventing the same scalability from the platform. Okay? Most, if not all of this data could be captured using Google Analytics, or there are much more extensive paid-for services that could deliver this functionality without it affecting our functionality of Magento and still capturing the data. We're just not capturing it in our database that we want to scale better for capturing payment and order transactions. One of the common things that comes up as a trend is modifying state outside of a HTTP post action. If you follow this simple rule at the bottom, only modify state on HTTP post, your application will be a lot easier to scale and will respect some of the common scaling scenarios and some of the other services that can be used. Also, it makes you very acutely aware of when you're doing write operations to the database, and as such can take further action. Offload functionality to third parties. That's a very philosophical approach and can often be contrary to what we seek to do as engineers. We like to solve problems. Sometimes somebody else has solved that problem a lot better, and it's already there and available to use. So speaking of logging, tracking users behavior, if you can offload that to somebody else and remove that write operation from Magento, then we've got more space for the operations we genuinely drive revenue. Okay? Although, marketing still need that information, we can gather it from other locations. Moving data and logic to the client is also an option. If state hasn't changed, as we were saying, don't change state without a post, then the client already has the data it needs. Step 8 is to introduce asynchronicity to your functionality. If you're in this morning's conversation about threading in PHP, I've got lots of ideas with that, and this is the sort of thing that we're talking about with regards to asynchronicity, not relying on everything being carried out in a single request-response loop in a single threaded operation, which is what is common in PHP. If we can have asynchronicity using job queues, we can offload non-critical write operations to something that will happen eventually. There's many solutions out there, from the entire MQ series to Gearman. You can connect to those very easily with PHP. You can pass them a message, a packet of data, and ask that to be written later. Again, it's about making sure we're only focusing on writing the data we need to capture a financial transaction. Anything that's updating admin grids, order grids, do we need that to be written at the same time? Arguably not. So we have an extensive amount of work using job queues so that we can delay that operation. It's still there later when an administrator or a marketing team need it, but we haven't blocked the consumer from actually checking out. Step 9, clustering and replication. Introducing a slave database, we can begin to separate our data, moving it to other hardware and offloading some of the work. But potentially we've introduced more work. moving data around. So using standard MySQL replication by enabling binary logging, but ensure you have compression enabled. Otherwise, you will potentially flood your network. If you've got a gigabit switch in your rack, or you're using a cloud network, it is feasible under high volume to flood that, and that's your communication between all of the servers will simply stop. It doesn't matter how much traffic you have. No communication is internally happening between the servers. Definitely use mixed binary logging. It's definitely quicker for replication. The default with MySQL is statement-based, and we have seen primary key clashes and very expensive replication between the clusters. And again, sorry for the typo on my slide there. It's a single-threaded replication prior to MySQL 5.6. So again, slave replication lag can be a serious consideration. But if we have two servers, or more than one server holding our data, we can begin to split read from write. We can access the data across a cluster, which again gives us more capacity and more throughput for reading and writing to our database. However, there's a potential problem with write-read consistency. We found in a couple of payment modules and a couple of other pieces of functionality where there's a transaction to write, and that transaction is closed, but there's an immediate transaction to read. If you're suffering slave replication lag because of high throughput, that following read won't resolve. You won't find the data that you genuinely expect to be there. So at the moment we have a mechanism for resolving that, which is to use a module level connection. So inside of your module config, you can overwrite what seems slightly counterintuitive. You can overwrite the read connection for the module to always use your write connection. It's the same way of interacting with MySQL, but you're always focusing your subsequent read for that module's functionality against a single database. It's not ideal, but it's a very pragmatic solution to ensuring you get data integrity. There are a number of clustering and replication options, and one of the ones that we've used to great success is Tungsten by Continuant. So on top of the standard MySQL replication with the open source MySQL products, they have MySQL Enterprise clustering, but we chose Tungsten for a slightly different reason. It layers on top of many database engines, and it has a great deal more functionality. The main one being its replicator, which is multi-threaded regardless of MySQL version, and its connection manager. The connection manager is probably the one factor which made this choice for us. It has what they term a smart connection manager, which is aware of the queries it's managing, and it's aware of all of the connections available within the cluster. So the connection manager provides high availability because it provides the ability to discover which nodes it can connect to for what types of operations, whether that's a read or a write. And that can be tailored based on the contents of the query. So if the query includes a write operation, you don't need to choose which connection pool you connect to. It will do that for you. The connection manager essentially runs on every node, so we've got redundancy. We don't have a single point of failure, and it allows us to move the master around the cluster of machines. We don't need to then modify Magento to connect to a specific machine, because it's always essentially connecting to the same node that it's running on, and the connection manager will handle that. This also gives us the ability to do direct MySQL upgrades. We can upgrade the version of MySQL, we can modify MySQL config, with zero downtime. We've run production clusters with a high volume customer at peak traffic, and we have moved the master database, restarted MySQL, changed configuration, and modified data, and the consumers never noticed. It never changed. We were a bit nervous the first time we did it. Subsequently, it's been essentially faultless, but we have a couple of gotchas coming later in the deck that hopefully other people won't suffer. But it's that service discovery from the connection manager that was the key decision maker for us. The ability to never have to touch the database config from Magento, but move where data was being written beyond that was really important for us. What are our next steps, though? Because this is all, I'm kind of replaying the journey we've been through to scale data for some of our larger clients. But there's some next steps. We're still thinking, what next? And one of the things that we're actually working on presently is the use of many connections. Because we've kind of discussed some of the potential settings that were causing problems for consumers for that forward-facing functionality of scaling the data. But those same settings don't really translate for the admin function. Sometimes we need a very specific mechanism, especially if we're running reporting or large-scale data changes. For example, some of the setup scripts, if you're upgrading Magento 112 to 113, that data upgrade step is a long-running process. The tuning of MySQL for that is very different to what we want for customer-facing connections. So we're trialing the idea of having specific connections for particular profiles. So we can then apply those to different modules in the Magento structure. So different modules have different characteristics. We're also looking strongly at alternate replication architecture, because as our customers become international stores, we're still currently bound by the idea of one master database where data is written to, and that's geographically bound in most cases to wherever the customer first starts, where they first make the choice of their hosting partner. Or it's still geographically bound, but in a cloud provider. When the customer becomes a true international store and other markets potentially start to overtake their original market, there's a strong question to be asked over where should data be written to and where should data be read from. So reading's a relatively easy one. We can set up a replication slave geographically close to where the customer sits. And that means that we have data available to be read at a much lower latency, and we can have the same response times for read operations. But for write, that's much harder. With Tungsten, we have the option of potentially putting a master write database geographically close to the consumer. So the write operations, again, aren't bound by any geographical latency. The problem there is, how do we get all of that data back into one place? Now, that might be a data warehousing solution or an ERP. But if we need it back into Magento, one of the options with Tungsten is the ability to set up what's called fan-in replication. So you can have many master databases where all the data is being fanned into one single point of record, one primary master. The benefits of using Tungsten over standard MySQL replication is the data can be rewritten during that process. So one of the obvious scenarios is that primary keys would clash between one master database and the next. With Tungsten, we can rewrite those primary keys. So they all get prefixed by a geographical key, Therefore, we avoid the clash. That's a rather crude simplification, but it's there as an option, and it's something we're looking at quite strongly. The other option might simply be sharding the data, taking some unique key from the geographic region, generating a unique hashing algorithm so that we can shard the data either into separate master databases or separate tables within that single database. Again, this is an idea around avoiding deadlock scenarios and getting greater write throughput. A few gotchas. We felt these. I hope you don't. Someone's got to feel them first time around. Someone's got to experience these problems. Turn off security updates. They are important. Definitely have them available to you. Don't have them applied automatically, especially not in a production cluster, because if they're applied automatically all at the same time, your high availability cluster doesn't know how to recover from every single node being down at the same time. Thankfully, it's easy to recover from, but avoid it in the first place would be a better idea. Ensure there's enough RAM for the transaction size. This is something you won't see every day, but again, in a highly merchandised site, if you have 30 people maintaining product, creating promotions, and they do that 8 hours a day, 5 days a week, the transaction size involved in rebuilding the indexes, we've seen them exceed 12 gigabytes in a single transaction of just data being written. So that transaction, I can guarantee, is going to go to disk rather than to memory, and your database is going to swap. So have your indexes being refreshed frequently, avoid the transaction size, and if you're using something like Tungsten or similar replicators, ensure they have enough RAM assigned to handle that transaction. So the final one, and I saw it mentioned earlier, file descriptors. It's a common one. You forget to do it, but you will, at some point, run out of them, and your machines will slow down. The engineers at Continuant are very good at checking this one. It's point 1 on the installation guide for Tungsten. But if you're using other solutions for replication, I definitely recommend checking that you have enough file descriptors. So that's kind of a summation of our journey towards scaling data. It's the steps we've taken. It's our thoughts for the future. So I'd like to open the floor for questions.
Any questions, Nigel, Mike? Any questions in the room? Any questions in the hallway?
Hi. You mentioned transaction levels and changing. The default is repeatable read, and you suggested moving to read committed. I wonder if you might be able to provide a little bit more detail on what the differences are. Okay.
So repeatable read, in that scenario, your transaction isolation level allows for a query that will persist data, will subsequently read that data, and then any reads following that are guaranteed. They will be consistent. With, sorry, I forget the alternate way around, sorry, the other value. The commit value only guarantees that the first read will be consistent. Okay.
Any other questions? I've got swag. Let's check the hall. No?
This one, just here.
You said it was sometimes worth rewriting a query. How about, is it worth rewriting it as a stored procedure? Because then the database will already have worked out a route onto how to get that data?
Potentially, but from our experience, we're not doing that simply because we're losing some of the flexibility. We restructure the queries within the framework, the ORM within the framework, rather than writing a stored procedure at the MySQL level. The queries we've looked at tend to be very dataset specific. So certain subselects being much bigger than perhaps they would be intended for originally. So those subselects become very slow, especially if they're wrapped into that single transaction. Potentially sounds counterintuitive. We definitely need metrics to validate our suggestion, but taking those out of that single transaction, we've seen better throughput by having an initial select followed by a select outside of that transaction.
Point to high availability. On the subject of high availability, how would you suggest one replicated data between data centers? That particular interest to me because I've got that problem right now.
Sure. The idea of replication between data centers is very valid. It's something we've done in the past for a number of clients. It can be done with standard MySQL replication. The problem you have is managing replication lag. So if those data centers have a direct backbone connection between them, then that's going to be less of a problem. But if your application is reliant on that replication being small seconds or small milliseconds, then you potentially have a problem that you have to manage, which is why we're looking to potentially have a solution whereby we can have a fan-in, moving the write and the read more geographically close.
I've heard some recommending MariaDB or Cheers. Hi, I've heard some people recommending MariaDB or Percona as alternative sort of variant DBs for Magento. What would you recommend for a fresh install?
We are generally using Percona as a default install. Essentially, they're the same database engine, but they've been the release cycles obviously have differed. The projects have begun to diverge. There's newer functionality, newer ideas in MariaDB and Percona compared with MySQL. We simply choose Percona because of our hosting partner support and the knowledge and awareness in the organization. We have MariaDB on our roadmap to review, and some of the functionality there looks very interesting.
That's like pretty.
Is there any point in separating logging to another database, for example, the visitor log, etc., instead of turning off, just to put them in a separate database with memory tables, etc., and then migrating them? That's
certainly an option and a very valid solution. The reason we haven't done that is simply because the clients either have an existing or are looking at alternate solutions that give them all of that data in a single place. Again, there's lots of solutions available where marketing and merchandising can be linked to that data very easily if it exists there first. So it becomes a redundant scenario in the Magento installation. You wouldn't necessarily get the same throughput because in the scenarios that we've done, it's actually offloaded completely away from your server and it's all happening client side. So for your hardware, there's much less work, and for the consumer, it's potentially quicker as well.
Any other questions?
One at the back.
Yeah, on the sharding, wouldn't it be very complicated because of the enormous amount of joins we see due to the EAV model?
It definitely would be complex. Definitely would be complex. It's something that we're looking at. It's probably a fairly crazy idea, but we're simply looking at it as an option. It's, from our perspective, the sorts of resources that we'd be looking to shard, because it wouldn't be all of the data, it would only be certain operations. They're fairly isolated, and even if we're sharding the initial write, we can potentially, in a background process, move the data back to a single location for use by administrators.
All right, we're getting noisy in the hallway, so thank you, Alistair.